Okay, number 24. We need to find all the vertical and horizontal asymptotes here. So the first thing we're going to do with all of these is factor as much as we can to see if we can cross anything off. So the top is going to become x minus 1 times x minus 1 all over x minus 4 times x plus 1. So nothing crosses off, which means there's no holes in the graph, so that's fine. So in order to find the vertical asymptotes, we set the denominator equal to 0. So x equals 4 and x equals negative 1. For horizontal asymptotes, what we need to look at is the highest exponent on top and on bottom. And since they're the same, we take the leading coefficients. So the horizontal asymptote will just be y equals 1. 25, same thing. We're going to factor as much as we can. Greatest common factor on top is a 2x. We take out a 2x, and we're left with an x plus 3. And on the bottom, I'm going to take out an x, and then we're left with x squared minus 3x minus 4, which is what we had in the last one. So it factored into x minus 4 times x plus 1. So what's nice here, the x's cross off, which means we have a hole where x equals 0. So that just eliminates x equals 0 as a vertical asymptote. So our new vertical asymptotes are x equals positive 4 and negative 1, just like the last one. As far as the horizontal asymptotes goes, since the exponent on bottom is bigger than the exponent on top, the vertical asymptote will just be y equals 0. If the exponent on top was bigger than the exponent on bottom by 1 degree, we would have a slant asymptote. But in calc, we're going to not do too much of that this year, probably at all. Okay, number 26, simplify the following. Remember, whenever we have negative exponents, we need to put it in the denominator. Now with this x to negative 3, we need to make it a separate fraction, 1 over x cubed. We can't put it in the denominator here because there's another term, that minus x there, that we can't separate it from. So 1 over x cubed minus x, 1 over x squared minus 1. I'm going to look at the common denominator now on top and on bottom. Those are over 1. So the common denominator would be x cubed. So we're going to multiply top and bottom by x cubed. So when we do that, on top, we're left with 1 over x cubed times x cubed is 1, minus x to the 4th, over x cubed over x squared is x, minus x cubed. Okay? I'm going to factor the top. That's a difference of squares, 1 plus x squared times 1 minus x squared. Take out an x on the bottom in GCF, 1 minus x squared. So the 1 minus x squared cross off, and we're left with 1 plus x squared over x. Okay, 27. What I'm going to do is find a common denominator on top and on bottom separately. So here I'm going to multiply this by 1 minus x, and here by x. And on the bottom, this by x, and this by 1 plus x. So a lot going on here. So the top is going to become x squared, plus, I'm going to FOIL this out, 1 plus x minus x squared, that's a difference of squares, all over x times 1 minus x. All over the bottom, I'm going to FOIL that out. We're going to get 1 minus x squared plus x squared over x times 1 plus x. So the x squared minus x squared crosses off, the minus x squared plus x squared crosses off, and we're left with 1 over x times 1 minus x divided by 1 over x times 1 plus x. So I'm just going to take that and multiply by the reciprocal now. X times 1 plus x all over 1. The x's cross off, so we're left with 1 plus x over 1 minus x.